Hello learners, I'm Akash. I completed my BTech from NIT Rourkela in the year 2020. Currently I'm a mathematics teacher. Now let us see how to solve this given question. Here I have to solve y square minus 2xy dx plus. This is a differential equation. Now I have to solve it. Okay. Now first what I'm going to do is I'm going to write it of the form dy by dx is equal to something. So that I can judge, okay, what kind of an equation it is. Kind of it helps. Okay. Now see, let's get started. This is what I'm given. Now send this term to the RHS, y square minus 2xy dx, send it to the RHS. So what I'd get is this, 2xy minus x square is minus of y square minus 2xy into dx, fine. Okay, I already mentioned to you that we need something of the form dy by dx is equal to something. So how am I going to get it? Just send this one here and get this one here. Uh, I sent this one here and dx here. So dy by dx is nothing but minus of y square minus 2xy divided by 2xy minus x square. Okay, now uh, this minus is there now, multiplied in the denominator. Okay, so I'll get y square minus 2xy by x square minus 2xy. Mark it as equation 1. Okay, this minus is there, right? I multiplied it in the denominator. So minus of 2xy minus x square is nothing but x square minus 2xy. Hope it makes sense. మీకు అర్థమవుతుందని అనుకుంటున్నాను. ఇప్పుడు దీన్ని అబ్జర్వ్ చేశారంటే మనకి ఏం తెలుస్తుందంటే ఇది ఒక homogeneous differential equation. It is a homogeneous differential equation. Okay, now what is a homogeneous differential equation? I do not want to cover it here, but this is a homogeneous differential equation. Once we know that it is a homogeneous differential equation, there is a method to solve it. What is that method? Is you put y is equal to vx. Okay, you put y is equal to vx, fine. Now differentiate both sides. Now differentiate both sides. Dy by dx is, here you have to apply uv rule, you know, right? uv dash plus vu dash, v into derivative of x plus x into derivative of v. Derivative of x is 1, derivative of v is dv by dx. So dy by dx is this. Okay, now these two substitutions, y equal to vx and dy by dx equal to this, put it in equation 1. Okay, now see, in my equation 1 what will it become? See carefully, in place of dy by dx, okay, in place of dy by dx, in place of this you will get this. Okay, in place of dy by dx you will see v plus x dv by dx is equal to uh, okay, whatever in the RHS. Now in place of y, in place of y, wherever you see y in this equation, here, here, not here, here. Okay, in these three places, in place of y, in place of y, you are going to get vx, you are going to get vx. Now with this happening, this is what you would get, v plus x dv by dx is this, vx whole square minus 2x into vx is nothing but x square minus 2x into vx, fine. Now next what can we do? Let's start simplifying the RHS a little. Vx whole square, what is ab whole power m? Ab whole power m is nothing but a power m into b power m. Okay, so this would be nothing but v square into x square minus 2x into vx. So 2vx square I'd get here. Here I'd get 2vx square, 2xx, so right, 2vx square. And I hope it's clear. Now in the numerator, if you'll observe, we can take something common. What can I take common in the numerator? Here there is x square, here there is x square. So in the numerator, I can take x square common. Likewise, in the denominator, I can take x square common. Okay, in the denominator also I can take x square common. So in the numerator, if I'll take x square common, I'm left out with v square minus 2v. In the denominator, if I'll take x square common, I'm left out with 1 minus 2v. Hope this makes sense. Now x square gone. This is what I'd get. Now what I want to do is I want to get all the v terms on one side and all the x terms on one side. Now how can I accomplish it? Is send this v to the RHS. Send this v to the RHS. Now what would I get is x dv by dx equal to this minus v. Next what? Okay, see, in case if you are not familiar, a by b minus c is nothing but a minus bc whole divided by b. That means this would go here. Okay, so likewise v square minus 2v by 1 minus 2v is send it here, v square minus 2v minus v into this by denominator, v square minus 2v minus v into 1 minus 2v by 1 minus 2v. I just took LCM here. Okay, that's why I would end up here. Now just multiply minus v into 1 is minus v, minus v into minus 2v is plus 2v square. Okay, so with these simplifications I get v square minus 2v minus v plus 2v square. What is v square plus 2v square? It is 3v square. Minus 2v minus v is nothing but minus 3v. So 3v square minus 3v by 1 minus 2v. This is what I would end up at. Fine, now I am here. I told you right originally I want all the v terms in one place and the x terms in one place. Now here, can I take something common in the numerator? Can I take something common in the numerator? Yes, I can take 3 common. If I'll do so, this is what I'd get: 3 into v square minus v by 1 minus 2v. This is what I would get. Now next, do cross multiplication. Send this 1 minus 2v here and send this dx here. Okay, now I already mentioned, right, I want all the v terms in one place. Now send this v square minus v to the LHS and send this x to the RHS. Okay, if you'll do so, 1 minus 2v by v square minus v is equal to 3 dx by x would come. Okay, 3 dx by x. Okay, great. Now we are here. What else to do? What else to do? Take minus common in the numerator. Okay, now you might be thinking, why should I take minus common? Guys, just observe the denominator. What is the denominator? It is v square minus v. Denominator లో ఏముందండి మనకు v square minus v ఉంది. అంటే ఏంటి? దీని డెరివేటివ్ ఏమవుతుంది? కాస్త ఆలోచించండి. డినామినేటర్ లో ఉన్న దాని డెరివేటివ్ ఏమవుతుంది? What would I get? What would be the derivative of this denominator? Okay, what would it be? Derivative of v square minus v is nothing but 2v minus 1. This one's derivative is nothing but is 2v minus 1. If you'll analyze the numerator, I have 1 minus 2v. The derivative of denominator is 2v minus 1, and in the numerator I have 1 minus 2v minus of this. Okay, so that's why I want to convert my numerator something like derivative of denominator. I want to write my numerator as something like derivative of denominator. On that note, I'm going to take minus common here. Okay, take minus common. Minus 1 minus 2v, I can write it as minus of 2v minus 1. You can cross check. You can just multiply this back inside. Minus of 2v plus 1. So 1 minus 2v. If you do so, you would end up getting the previous step. Now let me erase this because some of you get confused. Why did this come up? Now send this minus to the RHS. So 2v minus 1 dv by v square minus v is minus 3 dx by x. Now we are here. Stay focused guys. Don't get distracted. Okay, now next. Now just integrate on both sides. See, now I've got it in a form wherein I can start integrating. Now just integrate on both sides. Integral this is equal to integral minus 3 dx by dx. Fine. Now this is a constant minus 3. You can keep it outside of the integral. Now see, this 2v minus 1, I can write it as derivative of v square minus v. This 2v minus 1, I can write it as derivative of v square minus v. So this integral is of the form integral f dash x by f of x. F dash x is in the numerator, f of x is in the denominator. Now if I have an integral of this form, what would I end up with is log of v square minus v, means integral f dash x by f of x is nothing but log mod f of x plus c. But in textbook they have not used mod, so I'm not using mod here also. So log of v square minus v, this would, because you see here my f of x is this is my f of x, this is my f dash x, d by dv of this, right? So this is my f dash x. Okay, this is my f dash x. So integral f dash x by f of x is log mod f of x. That means log of f of x is this v square minus v. Okay, is equal to 1 by derivative of 1 by, integral 1 by x is log mod x. Again, I did not use log mod here because in the textbook they have not used mod, and since I integrated, I would get a constant, and that I'm taking it as log c. Hope this makes sense. Now what is v? V is something we have introduced. Okay, y equal to vx, so v will be y by x, v will be y equal to vx. If you remember in the beginning, I made this substitution. So y by x would be nothing but v. Fine. Now in place of v, just put y by x. So y by x log of y by x whole square minus y by x is Now there is a property, in logarithms. What does that state means? M log a is nothing but log of a power m. Okay, so basically if I have a coefficient, that would go to the power. So minus 3, just send it here. So log of x power minus 3 plus log c. Again, there is another property in logarithms which state that log a plus log b is log a plus log b is log ab. Okay, is log ab. That means log of x power minus 3 plus log c is nothing but log of c into x power minus 3. These two would get multiplied, c and x power minus 3. So this is what, before that I think, yeah, I wrote x power minus 3 as 1 by x power 3. That is another property from exponents. It states that a power minus m is nothing but 1 by a power m. Okay, so log of x power minus 3 is 1 by x power 3. So log of x power minus 3 is log of 1 by x power 3 plus log c. Now this would be nothing but log of 1 by x cube into c. I told that log a plus log b is log ab, so 1 by x cube into c. So this is what I get. Now here what I did is, uh, if you see here I have x square, so I'm trying to make this also x square, so multiply and divide by x, so xy by x square. So now these two have the same denominator, so y square minus xy by x square. Now log of y square minus xy by x square, this is what I would end up with. Now both of them have logs. Okay, both of them have logs. Now we can eliminate, now we can directly equate these two. Y square minus xy by x square is c by x cube. Now send this x cube to the LHS, so x cube into y square minus xy by x square. Now two x's cancel, one x will remain, x into y square minus xy is c. Can I take something common from this? Y square minus xy, can I take something common? Yes, there is a y and there is y square, so I can take a y common. So if I'll take y common, what I'm gonna end up with is xy into y minus x is c. This is what is the answer that is given at the back of the textbook. Okay, and we arrived at it. Thank you very much. I hope I didn't bore you. Okay, just to motivate you guys, or like, say something. Fine. See, initially now when you keep putting in efforts, result may not come. I mean, like, you may not see very significant change in your life. Like, let's say you start studying a subject, you start you start studying it, but you feel like you're not seeing significant changes, or you're not able to see significant success in that subject. Initially it will be there, small initial result is small, but if you keep putting in effort, keep putting in effort continuously, consistently, trust me, you will see compounding effect. And once compounding starts kicking in, oh my gosh, you will see great results of great improvement. So please be patient and continue doing things. Okay guys, thank you.